then it comes a matter of, over obviously a much broader spatial area than just this. So this is a great place to look for evidence of, the different specific pieces. Then it becomes a matter of piecing together the geologic story, of course, of a whole region, local to region to even broader. And so, at least the story of this one, we'll start with, as some people have said, and is certainly mentioned on your sheets, what's called the Grenville orogeny. And so this was, I'll just use broad numbers. Certainly, my area of expertise isn't in piecing together tectonic history, and so this is also based on the things that I've read and been on, frankly, previous field trips out here with people who have put this story together. But so the Grenville orogeny, was covered a large spatial area from, kind of where we are, as well as up into Scandinavia. Of course, this was before the Atlantic Ocean came apart. So there's recorded history of the same orogeny in parts of Scandinavia right now, and so covered a huge area. And mountain building generally kind of is directly tied to subduction zones. And so when you think about the large mountains of the world today, you have the Andes covering a large, distance of the planet, where you have oceanic crust subducting under continental crust of South America. What's the other, largest, great mountain range of the world? The Himalayas. And so it is not subduction exactly. What it is, but it is, rather than oceanic crust, converging with continental crust, right? The Himalayas today are continental crust converging with continental crust. And so in that scenario, neither piece of crust wants to go down because continental crust is less dense than oceanic crust. And so, right now we have, the Himalaya, again, as the highest, widest mountain range in the world because of the Indian plate and the, Asian plate coming together, and neither one of them wanting to go down. Now, the Grenville was also, broadly speaking, a subduction zone, and it was long enough lasted that it had a period of oceanic crust subducting under continental crust, and then at some point, the two continents came together, and so we are in a sense right around, broadly speaking, where that boundary would have been. And so during in a sense all of this, the mid to lower
Give
crust,
us a few minutes.
I don't know exactly the depths figured out from these rocks, but let me also say that garnets and various other minerals can be used to do paleobarometry, so figuring out what depth the mineral was crystallizing at. These were probably in the 15 to 20 kilometer range, kind of down into the crust, although honestly I would need to look at particular papers to know exactly what people figured out with these. So this is mid to basically mid crust. It's hot enough there that the rocks are metamorphosing and deforming, not so hot for them to just melt. And so, this is an area with tectonic compression and deformation, and basically that explains the formation of the gneiss and the folding in there as well. These, with the rock cycle, certainly these rocks would have been, had some sedimentary component in them beforehand from the surface, but over previous to that, with the geological history that there really isn't a whole lot of record of, and so we don't know all that well. Those rocks, the actual rock themselves made it to that mid-crustal sort of level. Then again, there is all this compression. Now, what is thought to happen, and this is, on the, it might help to look at the cross-section in the handout, but so there's this period of the Valley Springs gneiss being formed and the, subduction going on that was basically causing the oceanic crust to subduct and disappear. When the continents come together, then things get even more interesting. And in a sense, the observation is that you have the Llano uplift, you have the big granite bodies, Town Mountain granite, and basically the pink granites of Central Texas here, including at Enchanted Rock. Enchanted Rock is just a very small area of the bigger Llano uplift. And so, what the geological story needs to explain, i.e. the interpretation, is how we also get these big granite bodies, during the Grenville orogeny, but a little bit later than the ages of the gneiss. And the preferred interpretation is an interpretation is this, is that once the continents came together, the basically part of the oceanic crust that had been subducting to the sill kind of captured there, and the lower part, and basically the bottom of the lithosphere, the denser lower part of the lithosphere, basically broke off and started sinking. The technical term is delamination, and there's a variety of other kind of times and places that delamination has been